back to the CloudGuard portfolio project. My name is Mo and this is project 3 of my 100 project challenge. Today we are building an end-to-end customer churn prediction on AWS that saves businesses an estimated $1.8 million and achieves 92% prediction accuracy. This is a massive problem that every prediction-based organization faces, which is churn. This simply means turnover of customers. As we know, acquiring a new customer costs about 5 to 25 times more than keeping an existing one. But what if we have a system that could predict this churn rate and then we act to our predictions, and then that way we can save and manage our customers accurately? That is what we're going to be building with this project, to automatically predict the churn rate of customers, then manage them accordingly so that we can keep them. Instead of spending so much money trying to acquire new customers, we keep our existing customers. And this is what we're going to be building with this project. I'll be walking you through the whole project and every single thing we're going to be building. So let's go ahead and hop on and walk you through the architecture. The problem here is about a $1.8 million business problem, which is customer churn. And this is a silent revenue killer for subscription businesses because it's 5 to 25 times more expensive to acquire a new customer compared to retaining your existing customers. And also, this is more like a wasted effort for most marketing teams because this helps you target your marketing to the right customers. It saves you about 27% annual churn rates and also saves you about annual revenue loss of about $50 million. So what's the solution? The solution is proactive churn prediction using machine learning. So we're going to leverage machine learning to retain high value customers by predicting which customer is most likely to be a higher risk for churn. So this gives us early warning with the prediction system. So this predicts churn risks like 30 to 90 days in advance with like a 92% accuracy. So this helps organizations target their marketing to a particular sector of customers because of the risk of churn. And this is also precise because it focuses retention efforts on only high risk and high value customers. So if we have a high risk customer, if for example we have a telecommunications company and we have customers that are most likely to leave, we target marketing to them so that we can keep them by offering them so many values. It's also cost efficient because it reduces retention campaign costs by about 40%. Because you know who you're targeting, it reduces your retention efforts to just those you're targeting. It also improves customer lifetime value by 15% through proactive engagement. You know your customers, you've done your prediction, you know who's most likely to leave, and then you target your marketing towards them. So it helps transform reactive churn management into proactive revenue protection for the organization, saving you about $1.8 million. So this is a high-level overview of the architecture we're going to be building. Right here we have data ingestion. So we're going to be using raw data from Telco data by IBM, and it's going to be uploaded into our S3 bucket right here. And then SageMaker processing job is going to be triggered to clean, transform, and engineer features from the raw data uploaded into S3. So this SageMaker is going to read data from the S3 and transform every single thing. The processing job right here. So the feature store here ingests the process job into SageMaker feature group, and this provides a centralized, consistent source of features for training and inference of our data. Now, the SageMaker Autopilot here, using the feature groups as its data source, and then automatically explores different algorithms and hyperparameters to find the best model. It uses XGBoost and other algorithms to find the best model for. After Autopilot identifies the best model candidate, the SageMaker Clarify job is run to analyze the model. So in this project, we're not actually using SageMaker Clarify because I exceeded my quota limit, but I'll just explain what this SageMaker Clarify was supposed to do for us. So the SageMaker Clarify job is supposed to be run to analyze the model and generate explainability. The SageMaker job was supposed to be run to analyze the model and generate an explainability report using sharp values to understand which features are most influential in predicting the churn. So this This clarify is supposed to detect the bias in our data, but because of service quota limit for us, we didn't really use the clarify, we just deployed it. So here the best model is deployed to a SageMaker endpoint for real-time prediction. And for monitoring here, we could use the either QuickSight to monitor. We can also use CloudWatch to monitor our predictions. So for GRC compliance and governance, we are aligning AI operations with global regulatory standards here. So it complies with the NIST AI RMF, the ISO 42001, and then the GDPR Article 22. The business impact and ROI here, we have quantifiable value delivered through proactive churn prevention. Because we are proactively detecting churn, we can save about $1.8 million every year. We have a retention uplift of about 15%, like improving overall customer retention rate. And then this is just an overall explanation of what we are providing to the organization and saving money at the end of the year. So we have about 450% 3-year ROI. So let's go ahead and jump into the AWS console and build a project. Alright, let's start building here. So the first thing we're going to do is to go into our IAM and then create our role. I've already created our role here. We have two main permissions here, S3 full access, since we're going to be writing and reading from S3, and then SageMaker full access here. Go ahead and create your own roles. And then the next thing we're going to do is to jump into SageMaker. Go to SageMaker, go to notebooks. I've created my notebook. I'm using T3 medium for my instance. And then once you create your notebook, it's going to use the same role you created in IAM, and then go ahead and open your Jupyter notebook here. So once you click on open Jupyter, it should take you right here, and then when you're right here, click on new and then open the Kanda Python 3. Then it should give you this IDE right here, and here is all the code we're going to be running. The first few cells 0 through 3, are going to be setting up our environment. So we are going to be working with Telco Churn dataset by IBM. So here the cell 1 is just going to check to see if our SageMaker endpoint and everything is ready, is good to go. And then cell 1 is going to help us download the dataset from GitHub, and then cell 2 is going to set it up for us. So let's go ahead right now and run cell 0. Just click there and run. It's going to take a few minutes. By the way, if you get this error right here, this is completely normal. But what it's saying is here, we have our SageMaker environment is running. We are in US East 1, and this is the role it assumed, which is fine. Everything is going on well. So now let's go ahead here and download and verify our download. So once we download this, we're going to verify and make sure everything is good. So let's go ahead and click on thing. There you go. So we have the data downloaded already, and the file size is about 19,455 bytes. Awesome. Now cell 2 is gonna help us initialize our session, our S3 bucket, set up our prefix and the IAM role. So here is gonna initialize the session, set up our bucket for us, use the execution role, and then name our region for us. So let's go ahead and then run this one too. Should take just 1 or 2 minutes. There you go. The session has been complete. Our S3 bucket is right here in US East 1, and this is our prefix for us. So if you go to S3 right now, go to buckets, we should see our buckets here created already. So next is we're gonna do here is cell 3. Now cell 3, like you know, with all ML, data is everything. So we need to make sure we clean our data, make sure everything is good. We load our data, we load the raw data, clean the data, make sure there's no missing rows, make sure everything is good. Like we need a very, very good data. So right here, we're just gonna run this one to help us clean our data before we start the main deployment and training. Here, let's see, it's going, everything is loading, everything has generated, everything is good, everything has been deployed successfully. Awesome. So now the next thing is to run our cell 4. Now cell 4 is where all of our data transformation happens. We are running this entire script here locally within our notebook, and this is because if we run this in SageMaker, we're going to hit the service quota limit. So I'm running this one locally in the notebook, which is cheaper and faster for us. So we're gonna just go through every single thing and run. So here it's gonna create a feature store for us. It's gonna process the data, create a feature group name here, load feature definitions by data frame. So this is just gonna work mainly on the feature group. So let's go ahead and run this one, and it should take about 1 or 2 minutes to to be created. And there you have it. Our cell 4 is done running. Everything is good. So this cell 4 is packed with a lot of best practice. So next we're going to be running our cell 5. So in cell 5, we create and ingest our data from a SageMaker feature group. And here we run our autopilot, define the input of our autopilot. So right now, let's go ahead and click and then run cell 5. So our cell 5 has completed. It took about 30 minutes to complete, but right here it's completed. It's predicted our best candidate AI model for us right here. Next, we're going to run the clarify job. The clarify job is supposed to help us detect any bias in our data set or model. So right now I'm just going ahead and run it. It should take about maybe 10 to 15 minutes or so, but right here is running. So let's wait and see. Most times it hits AWS service quota limit. So if it does, then we're going to just bypass it and just deploy the model. But if it doesn't, then it's going to detect any bias in our data set for us. So let's go ahead and wait and see what it does, if it's going to fail. So our clarify job failed right here. And like I said, it's going to fail, but we'll just try to run it and see if it's going to go. Now let's deploy our model. Here in cell 7, we take the best candidates from the autopilot and deploy it to real SageMaker endpoint. So we are using a T2 medium right here. So I'm going to go ahead and deploy. Right now it's deploying. It will take about 5 to 8 minutes to deploy. So the whole project overall takes almost an hour to run. So if you are running this, make sure you run it in a particular time. That way you don't incur additional costs over a long period of time. Our endpoint has been deployed. There it is, it deployed successfully. So with the endpoint live now, we can test it by running some tests to see if it actually works. So this is where we're going to be running the cell 8 here. So we're going to go ahead and run the test. But what the test is basically going to do is it's going to help us make predictions. So the prediction we're going to be saying is, if we have a result of close to 1, this indicates that there's a high probability of churn for the customers. If we have a result of 0, it indicates that there's a low probability of churn. But a threshold of 0.5 is typically normal, but we can adjust based on the business needs to fine-tune it more and to get whatever we want from it. So right now, let's go ahead and run the tests. And here we go. Here's our prediction here. So we have 5 predictions made for customer 1. We have sending 42 values and a result of 1. So this means this customer has high churn rates, and this other customer has a result of 0, low churn rate. This one low churn rate, and this one has a 1, which is a high churn rate. So basically, in business context, what this typically means is the customer with a 1 has a higher rate of leaving the company. So you want to start doing immediate retention campaign with probably personalized offer for this customer. But for those with a churn rate of 0 prediction, there's no indication of them leaving pretty soon. So probably standard customer service will work for these people. But those with the higher churn rate, you need more customized customer service campaign for them. That way you can keep them. As we know, it costs more to get a new customer than to keep an existing customer. So this is it. This is the end of our churn rate prediction here. The next thing we're going to do is just to clean up, and to clean up we're going to run our cleanup code here, which is going to help us clean up every single cell. Since everything is SDK based, it's easier for us to just run the code and it goes in there and cleans up everything for us. So right here is the code to clean up. It's going to go ahead and delete our S3 bucket, our feature group. Let's just go ahead and run this. It should take a few seconds. And there you go. Everything has been completed. But even though this has been deleted, we still have to go back and delete our notebook instance and also the IAM role we created earlier. So let's go ahead and go back to our notebook. So here our notebook instance, click on it, stop. Once it's stopped, we'll go ahead and come back and delete it. Go to our IAM, go to our roles, and then delete the role. Our S3 bucket should have been deleted for us. It's empty, so we'll just go ahead and delete the S3 buckets. Then if we go back up to SageMaker are endpoints. And go ahead and delete. So these are still in service. Let's go ahead and delete this. Delete. Now go ahead and delete the notebook instance. So with everything we've created, if you go to CloudWatch, you will see that we'll have some log groups here created for us. If you don't need them, just go ahead and select them and delete the log groups. And that is it. Alright, that was project 3 of my CloudGuard portfolio project, Customer Churn Prediction. Let's go ahead and recap on everything we built. So we built a production-grade MLOps platform with SageMaker Feature Store for centralized feature management, SageMaker Autopilot for automated model training and tuning. And then we use SageMaker, we didn't really use SageMaker Clarify, but we're supposed to use SageMaker Clarify for model explainability, because it failed. We didn't use it. We demonstrated how to engineer features at scale, how to use AutoML to save weeks of manual work, and how to generate sharp values. Coming up next is going to be project 4, which is going to be the automated model registry and versioning system. So we're going to be building a complete CI/CD, MLOps CI/CD pipeline. If you found this helpful, please hit the subscribe button and drop a comment below. Let me know which AWS service you want to see in the next project. That way we can build it together. Thank you for watching, and I'll see you next time.